Okay, this is the second page of lesson 4.1, 4.2. So we're going to be looking at solving and verifying solutions. So this first question, we're going to collect all the like terms on the one side. You get 9x. And on the other side, you get 3x, subtract 12. And then we're going to bring the 3x over through subtraction, leaving the minus 12 on that side. And then divide off the coefficient of 6. Okay, so we've solved the equation and we've got the answer of -2. We're now going to formally verify that that answer is correct. And the way you do this is you use the left side and the right side of the original equation, and the answer of x is -2. So it's always important that you take the original left side, right side. Don't take some version of it down here because you've contaminated it and could have made it incorrect. Always start with the original. Okay, the way you do this is you're just going to plug in -2 into this side. And you're going to remember to use brackets. That's -18. And on this side, do the same for the right side of the equation. Oops, and I see that these two 6's here are both negative and they cancel with the 12, leaving -18. Okay, so what I've done is I've just gone and I've solved this equation and I got an answer of x is -2. I want to know if that's correct. Well, if it's correct, it should work if I plug it back into this equation. So of course, if I plug it back in, I could do that in my head and just kind of go along and see if it matches and works, or I could use a calculator. And that's how you should do when you're verifying solutions. You should check that they work, that they make sense. But the formal way to do it is, of course, to use left side, right side proof, and to write down the left side separately from the right side and see that the two sides match. So this is basically plugging in and saying that, yes, when I plug in here, I get -18, and when I plug in there, I also get -18. So we're good. Left side is equal to the right side, and therefore x indeed equals -2. Now, if it doesn't equal, left side and right side don't equal, you need to go back and look to see if you made a little mistake somewhere, or if indeed you made the mistake here. So the idea is that this is a way to find an error, and the error could be one of any of these three places. If you get the wrong answer here, they don't match, go back and find your mistake and then fix it. Sometimes you'll get a question on a test, for example, where they'll say, you know, so-and-so solved this equation and they got this answer. Verify that it's correct. They're, you know, they haven't shown you how they got the answer. You could also redo it yourself to see, but they want you to plug into the left side and the right side. And if the two sides don't match, double check that you didn't make a mistake. But if you didn't, just conclude that the left side and the right side do not equal each other. You put a line through here to say they don't equal each other. Therefore, x does not equal -2. Don't pretend that they match when they don't, because then that just creates another error. Because sometimes the teacher wants to check that you understand what it means if your answers on the left side and the right side are not the same. Okay, second one, we're just going to distribute over the 6. 18x subtract 24. Distribute over the -1, the minus. Okay, then we're going to group on this side. 21x subtract 25 equals -67. 21x equals -67 plus 25. So down 67 and then up 25 is the difference. -42. 21x. And then divide off the coefficient. -2. Okay, happens to be the same answer. Okay, we're going to verify that the answer does indeed equal -2, and we're going to do that by doing the left side and going up and getting the left side of our equation from here and rewriting it. Okay, and then remember to use brackets for substituting. just carry on and figure out what this is. Working with bedmass inside the brackets first. Ta-da! We got negative 67 for the left side. Now we're ready to do our right side, which is always done separately from the left side. Go up and get it. Oh, look at that. No work to do. It's just negative 67. And so there's no work to do. Left side is equal to the right side. Therefore, x equals negative 2. Sometimes they write this symbol. It's upside down triangle, and that means since the left side equals the right side. And then this means therefore x is equal to negative 2. Okay, so that's formally verifying equations. And the last thing is solving equations with decimals. Basically, I'd get rid of all the decimals first and then state it as a fraction. This is the same thing as oh, you haven't done it yet. The next lesson is going to talk about solving equations with fractions, and this is kind of a version of that. Okay, so you can see that they all have one decimal place. They all have tenths in them. If you multiplied both sides by 10, you would eliminate the decimals. If it had 2 decimal places, you'd multiply by 100. So if you multiply this by 10, you're going to get 6. And this next one, you're going to get 18t and 32. And voila! In one step, you got rid of all your decimals. So negative 18t equals 32. Actually, I should write it. 32 subtract 6. And negative 18t equals 26. And divide off the coefficient. And that is equal to negative 13 over 9. Okay. I mean, if you were to look at that original question, this is getting ready for next lesson. 0.6 is the same as 6 over 10. 1.8 is the same as 18 over t, and sorry, 18 over 10. And 3.2 is the same as 32 over 10. I mean, that's how you would write those decimals as fractions. And now you can see they're all divided by 10. If I were to multiply both sides by 10, which is the same thing I did over there, you could see that when you distribute on this side, the 10s would cancel and that 10 would cancel, leaving you 6 minus 18t, and these 10s would cancel 32, which is exactly the same thing we just did. And that's what you're going to be learning next day in solving equations with fractions. Okay, that's the end of that lesson. Bye-bye.